Hello. Today I will be talking about what transport medias or medium. What are transport media? These are the ways through which what materials, digested food, proteins, hormones are moved around the bodies. And we have majorly four transport medium. That includes the blood, the lymph, the cytoplasm, and the last one being what cell sap. It's called cell sap or latex. The first two is used by what human being for transportation around the body. This is used by what unicellular organism. Example is what the amoeba, the chlamydomonas, the euglena. All the microscopic organism uses what cytoplasm. While the cell sap is used by what the plants, majorly the trees, because a simple plant can actually deal with what only diffusion and what osmosis for each what transportation of what material. But when once the plant becomes what complex, it needs a transport what medium for that. Now, if I focus on the blood, like in human being, we will say that the blood in human being is what is red in color. That is for human being. But in some other animals, it may not just be what red, because the blood is red because it contains what hemoglobin, which is made from what the iron what component. Now, this blood in human beings is divided into what two parts: the solid part of the blood and the lipid part of the blood. The solid part of the blood are what the blood corpuscles or the blood cells. The blood corpuscles has to do with what the red blood cell, the white blood cell, the platelets. Then another name for the red blood cell is what erythrocytes. Another name for the what the white blood cell is what the leukocyte. That's for the white blood cell. Remember, I said for red blood cell is what erythrocyte. While for the what the platelets can equally be called what the thrombocyte. This red blood cell helps in what in the transportation of what oxygen around the body. And remember, they are biconcave in what in shape. Then white blood cell is what serves as what the body defense what mechanism. Then they don't have shape. They have what they are shapeless actually. And remember, but they have what nucleus, but the red blood cell doesn't have what nucleus. Why the thrombocyte helps in what in blood clotting? What does it do? Should in case there is a what an exposure of your what that's a rupture in your skin to the atmosphere. If it is just a small bruises, it causes what all the involuntary muscles around that place to contract, thereby sealing up the wound or reduce the rate of what blood outflow. Now, if the rate of maybe the wound you have in the body is a little bit higher than that, what would this thrombocyte do? It's gonna what cause what a blood protein known as what the thrombokinase. Thrombokinase. This thrombokinase convert another blood tropin known as blood protein known as what thrombin. Convert thrombin to what prothrombin to what thrombin. While the thrombin on the other hand will convert what another what blood protein known as what the fibrinogen. That's to what fibrin. That's the thrombin does that. That's the process of what blood clotting. Now, this is the final thing actually what seals up the wound, the wound. Now, you must remember that what this blood clotting is only what efficient if their level of what vitamin K in your system, that's the phenotype, is what actually high. And if it is not high, especially in the male what the male body, if the level of vitamin K is not what actually high, you notice that what these things can't easily happen. And they say the person suffers from what hemophilia, that's the inability of the blood to clot as a result of what lack of what vitamin K. And the person that suffers from lack of what vitamin K is known as what hemophiliac. Then the disease, that the condition, the disease itself is known as what hemophilia, and is only manifestable in the male gender, but not in the female gender. So therefore, the females are the carriers of this um, hemophilia disease, and then we are the ones actually what suffer it as a male gender. Now, there are some cases too in which what the blood just tend to what clot in your vein without actually being what exposed to the atmosphere. If the blood actually is clotting in your vein without actually being exposed to the atmosphere, it's known as what the thrombus. If this thrombus happens to be what mobile in your system, therefore it will be called what? The embolus. But that doesn't actually happen very often. Why? Because there's what? A natural anticoagulant in your system that prevents the blood from what? Clotting unnecessarily. And that is known as what? The heparin, as that may sound. That's a natural anticoagulant in your system. And you must remember that we have what? The four blood groups. We have four blood groups majorly, which is blood group what? The A, we have the what? The B, we have the what? The AB, and we have the what? The O. The AB is known as what? The unifacial what? Recipient, because he can receive blood from blood group A, B, AB itself, and O. But O is known as what? Universal donor. Why? Because O can give blood to all these four blood groups. So therefore, it's known as what? Universal donor. Remember, if you have blood group O, you can give to everybody, but only those in O can give to you. Then when you have blood group AB, you can receive from what? All the blood groups, but can only give back to what? AB. Such a very what? Selfish blood group. Like I said earlier, that what is very into what that the blood is very into what through section. That's what the blood cells, which is that's the blood cells and what the liquid part of it known as what the plasma. So the liquid part of blood is known as what the plasma. Now, generally we have two types of what the circulatory system. We have the first one being what the open circulatory system, and the second one being what the closed circulatory system. In this open doesn't mean that the blood will flow outside. No, it means there's a particular section in your body where both the oxygenated blood and the deoxygenated blood meet for exchange of what? Materials. Because that doesn't happen in the closed system. For the closed system, they don't actually meet at a particular junction to exchange what? Materials. That particular junction in the open circulatory system where all the oxygenated blood and the oxygenated blood meet for exchange of material is generally known as what? The what? The homocele. So you can look up the spelling, the homocele. That is it. So if you want to what? Represent the circulation of blood, that's for the open circulatory system, you will have the what? The body organs here. After the body organs, you will have the what? The lungs. Okay, let me just say the heart here. From the heart, it will now move to the what? The lung. Let me use it in triangular form. I have the lungs. The organ may be using gills or whatever you use for respiration. That's the function of the lungs to supply what? Oxygen. So I'm using lungs here. You can actually use the gill. So if these are the body organs that are linked up in this manner, the blood flows from the body organs to the heart, and the heart pumps to the lungs, and the lungs send it back to the body organs. That is for what? The open circulatory system. And if you notice in this diagram, the type of blood that is always coming to the heart is the deoxygenated blood. What are the qualities of what deoxygenated blood? Is what? Dark colored red. It's not bright red. If it's bright red, simply means what? Oxygenated blood. So any type of heart that only carries what? The deoxygenated blood is known as what? The venous heart. That's the venous what? Heart. It's a type of heart that only carries what? Deoxygenated blood. And animals normally what? Exhibit this kind of what? Open circulatory system are normally found on what? Under the what? The cold-blooded animals. And know that what? Another name for cold-blooded animals can also be called what? The poikilothermic what? Animals. They don't tend to maintain a constant temperature, unlike us. Now, having said that, over to the what? The other type of circulatory system known as what? The closed circulatory system. For the closed circulatory system, note that the blood has to pass through the heart 2 times for complete what? Circulation. So I have the body organ seated once more here upon the throne. Then I have the what? The lungs. That is the source that actually will supplies the oxygen. Now, then blood move from the body organs to the heart. The body returns to the lung again returning to the heart now pump it to the body organ again. Then that is the way it's going to move to you. That's for complete that. If you notice that the blood comes to the heart first on its way towards to the lung. And from the lung, from the heart moves to the lungs again and return again to the heart. Simply means it is passing through the heart for what? 2 times, For complete circulation in the closed circulatory system, the blood has to pass through the heart twice for complete that. Now, all the blood that are in this section are normally what? The deoxygenated blood. That's dark colored blood. Then the one that are here are normally what? The oxygenated blood. Now, under this closed circulatory system, there are different types found under it. So, in that, one of them being that what the circulation of what blood between the body organs and the heart is normally called what the systemic circulatory system. Either you call it systemic circulatory system, or you call it what greater circulatory system. Why is it greater? It is pumping blood from your head to your toe, so the distance is covered is what much larger when you compare for the pumping of blood between the heart and the lungs. So the other one between the heart and the lungs is known as what the pulmonary circulatory system, or you call it what the lesser circulatory system. Of course, whenever it has to do with the lungs, it has to do with what the pulmonary circulatory system. Or should I say the pulmonary artery supply blood to the lungs? Yes, I'm right. Or should I say the renal artery supply what blood to the what kidney? Yes, I'm right. If I hear pulmonary, it talks about the lung. I hear about renal, it talks about the what the kidney. But what about the blood vessels that supply blood to the head? Would you guess? That's what the carotid artery. What about the one that supplies to the small intestine? Known as what the mesenteric artery, gonadial artery to the what the gonads, and so on and so forth. Now, systemic or greater, then pulmonary or lesser. In this heart now, part of it is carrying what deoxygenated blood, while the other part is carrying what oxygenated blood, and they don't mix in the heart. So this compartment that normally will divide the heart into two for preventing them from what stop mix is known as what septum. That is what prevent the blood from what mixing together. That's what divide the heart into what the right part and the left part of it. Now, I would like to give you what a clear picture of what the heart or what normally happens in the heart during what the circulation of what blood. Permit me, my drawing may not be as perfect as the one you have seen online or the ones in your textbook, but the idea here is to explain what normally happens during what circulatory what or circulation of blood around the heart, known as what the coronary what circulatory system. The heart is designed to pump blood from the time you were conceived to the time you die. The muscles of the heart don't actually what get weak the way our normal bodies or maybe normal muscle does, and those kind of muscles are known as what cardiac muscle. Why is it that they don't get weak? Can you guess? It is because they do not produce this acid, lactic acid. This acid actually makes the muscle to be weak, and that's what we find in our bicep or our triceps and the rest of the body that actually makes them weak. But in the heart, that acid is not found there. Now, if I am talking about the heart, it's located somewhere on the left part of my arm. That's behind the septum or the breastbone. That's the bone that is lying around here on the chest. Now, this is the left part of my hand. This is the right part. Now, the moment I am talking about somebody's hand, I'm placing it this way, it rotates. That's talking about the anatomy of somebody else. So everything I am doing, it will turn to this place with the left part of it. Though this is the right part of my hand, but remember, the left part of my heart is this way, while this part is the right part. So there should be the septum somewhere around here, and it is that way. I have the ventricles. Remember, the heart has 4 chambers. The upper chambers are the auricles, while the lower chambers are the ventricles. So if I have the ventricles at the lower chamber here, the left part of the heart is thicker than the right part of the heart. Why? Because it is a left ventricle that actually pumps blood all around the body. So therefore, it has to be thicker to take such pressure. And because it's thicker, so I'm going to make here to be a little bit thicker. Yeah, and here to be thinner. And as that happens, it sends out again to form this. There are 4 blood vessels actually entering the upper chamber of the heart. That's from the left part. And this blood vessel normally carries oxygenated blood from the lungs. So I'm just going to represent 2 of them. So as it thickens here, I'm coming. So I'll make a hole here. So that's the first one entering there. We have the second one entering there. Now, as I have it in that manner, there should be another valve from this section. Yes, not so wide. Now, here we are. And there should be another one somewhere around here. So what have I done? This is a chamber on its own, which is what? The upper auricle for the left part, and here I have the what? The lower what? Ventricle for the left part of the heart. So what does it do? This oxygenated blood enter from the lungs into the what? The left auricle, and from there it allows them to pass through this place into the what? The left ventricle, which automatically pumps it back through the major blood vessel, leaving the heart carrying what? Oxygenated blood, which is what? The aorta, like this. Now, this valve that actually works here only allows blood to only flow in through one direction. It does not allow blood to go back. And the name of the valve that is here is known as what? The mitral valve. Another name for mitral valve is what? The bicuspid valve. So the valve actually what? Prevent blood from flowing what? In one direction. And it is a valve found between the what? The left auricle and the left what? Ventricle. Now, and you must know that these blood vessels are bringing blood from the what? The lungs to the what? The vein, and known as what? Pulmonary what? Vein. Pulmonary vein. And all veins carries what? Deoxygenated blood, except the pulmonary vein. Veins are blood vessels that carries blood towards the heart, while the blood vessel that carries blood away from the heart, and known as what? The arteries. And all veins carries what? Deoxygenated blood, except the pulmonary vein. While all arteries carries what? Oxygenated blood, except the pulmonary artery, which I'm about to represent on the what? The right part of the what? The heart. Now, that will continue from this place, which will eventually thickens out to be in this manner. But unfortunately, so in his own, he has a pipe here, another blood vessel coming to this way, and there should be a major one from this part again, leaving from here to this part, and that should actually close up to this part. So what have I represented? I've done the what? The upper auricle and the what? The lower what? Ventricle for the right part of the heart. Now, this one that's pumping, facing up, collect blood from what? All body parts above the what? The heart. That's from my head. So this level empties into the heart, and it's known as what? The superior vena cava. While the one that's below here is known as what? The inferior vena cava. So what does it do? This one collects blood from all other body parts beneath the what? The heart. So why this one takes from what? Body parts above the what? The heart, and empty it into this what? The right auricle, which now allows it to pass through this what? Valve again. Remember, this is known as what? Mitral valve. But this one on the right part of the what? The heart is known as what? The tricuspid valve. Tricuspid valve is called, there are something like cusp. Remember, cusp, that's like a preventive, let's say, a tissues that actually will prevent the blood. So in the left part there are two, and in the right part there are what? Three. That's why I'm having tri, and that one is bi. That's two cups there, three cups here, and it allows it to flow through while these pump it back through the walls. And remember, here must at least branching towards two. While it's pumping it out of the heart through the walls, the I have the what? The pulmonary artery. So as it enters through the wall, the right auricle and the right ventricle pump it again through the pulmonary artery, and as it's leaving from the pulmonary artery, is going to what? The lungs to be what? Oxygenated. So only pulmonary arteries carries what? The oxygenated blood, and the left or the right part of the hand of the heart, I mean to say, contains what? The oxygenated blood, while the left part contains what? The oxygenated blood. Now, these two valves that are here actually that prevent what? The blood from what? Coming back, because they don't allow back to blood to flow back. They only allow them to flow what? In one direction, as the way they've been designed, are collectively known as what? The semilunar valve. Now, a heart equally has tissues surrounding what? at the outer part of it actually will prevent what over expansion of the heart and makes the heart work more efficiently. So that is known as what the pericardium. Pericardium. And at the inner part of the heart, another tissue is there, actually what makes the inner part of the heart to be what smooth. That's known as what the endocardium. The endocardium. While in between them, as I have it this way, is known as what the myocardium. Yes. So these three muscles, the pericardium, the endocardium, myocardium, actually working in order to bring what the efficient expansion and contraction of the heart. Now, these auricles help you actually what contract to send blood down to the ventricle. That contraction of the auricle, which is the upper chambers of the heart, is actually known as what? The diastole. While the contraction of the ventricles to pump blood out of the heart is known as what? The systole. Now, for an average human being, the male gender, the heart weighs about what? 250 grams. While for the female, it's about what? 225 grams as a weight. And you must know that what the body has a relationship with the heart. The larger the body, the smaller the heartbeat. But the smaller the body, the faster the heartbeat. Compare the heartbeat of an elephant to that of a rat. Elephant may probably experience 12 to 14 heartbeats per minute, but a rat may exceed more than that. For instance, for an average human being, we have about what 72 heartbeats per minute. That is the normal heartbeat for human being, and that's actually what increase during what exercise in terms of what fear or anger. Now, when the heartbeat has actually become what erratic or has increased as a result of what condition, that is known as what arrhythmia. That's the abnormal heartbeat. And there are cases where it manually what increase or decrease. If it increases, it's known as what tachycardia. If it decreases, it's known as what bradycardia. It can decrease as a result of what old age or some kind of what mental illness that can cause what the heart to what decrease what its heartbeat. That is for that one. And the instrument for measuring what the blood pressure is known as what the sphygmomanometer. That's sphygmomanometer. And it's normally recorded as 120 over 80 for normal heartbeat. This represents what the systole, the way it's supposed to be. This represents what the diastole, the way it's supposed to be. So the two ratios comprises what the normal what heartbeat. Now, this was for what the anatomy of the heart, or what normally takes place or